So here we have the function x sine of x plus cosine of x multiplied to x cos of x minus sine of x. So we begin by treating x sine x plus cosine of x as the first function and x cosine of x minus sine of x as the second function. So let us find the derivative. So we have the derivative of this given function will be x sine of x plus cosine of x multiplied to the derivative of the second function, which is x cosine of x minus sine of x, plus consider the second function x cosine of x minus sine of x and multiply it to the derivative of the first function, which is x sine x plus cosine of x, which will give us x sine of x plus cosine of x multiplied to, now we're going to apply the derivative to each of the terms. So we have the derivative of x cosine of x minus the derivative of sine of x plus x cosine of x minus sine of x multiplied to the derivative of x sine x plus the derivative of cosine of x. So that is going to give us x sine of x plus cosine of x times, now we again have the derivative of x cos x, where we can apply the product rule. So we assume x as the first function, so we have x times the derivative of the second function, which is cosine of x, plus cosine of x multiplied to the derivative of the first function, which is x, minus the derivative of the sine function gives us cosine of x, plus x cosine of x minus sine of x multiplied to the derivative. So we have x sine of x, where we can apply the product rule. So we have x times the derivative of sine of x plus sine of x times the derivative of x, and plus we have the derivative of the cosine function, which gives us negative sine x. So we have x sine x plus cosine of x multiplied to x times derivative of cosine of x. So derivative of cosine of x is negative sine x, so that multiplied to x gives us negative x sine x plus cosine of x minus cosine of x plus x cos of x minus sine x times x times derivative of the sine function is cosine of x plus sine of x times the derivative of x, which is 1, minus sine of x. Now here we can see that there are some additive inverses here, so cosine of x and negative cosine of x cancels out, and in the second term sine of x and negative sine of x cancels out. So we get x sine of x plus cosine of x multiplied to negative x sine x plus x cosine of x minus sine x multiplied to x cosine of x. So this is the derivative. So we can stop here, but what we can do is we can further simplify this given expression. So let us do that as well. So we are going to distribute negative x sine x with the two terms, x sine x and cosine of x. So we have negative, so x sine x multiplied to negative x sine x will give us negative x squared sine squared x. Then we have cosine of x multiplied to negative x sine x, so that will be negative x cosine of x times sine x. Similarly, we distribute x cosine of x with x cosine of x minus sine of x. So we'll have plus x squared cosine squared x, negative sine x multiplied to x cosine of x will be negative x sine x times cosine of x. Now we consider the first term and the third term. So here we have x squared, which is the common term. So we factor it out, so that is going to leave us with, so we consider the positive term first, sine squared x minus sine squared x. Then we have the second term and the fourth term. Now both of them are the same term, it's repeating two times. So we have negative 2x cosine of x times sine of x. Now cosine squared x minus sine squared x is an identity, which is cosine of 2x. And here let me rewrite this. So let me write x first, then 2. So we have x times 2 cosine of x times sine of x. So this is another identity which is equals to sine 2x. So we have x squared multiplied to cosine of 2x minus x times, so 2 times cosine of x times sine of x is sine 2x. So we can take x as the common factor, so that leaves us with x times cosine of 2x minus sine 2x. So this is the final answer, and this is the derivative of our given function. So let's move on to the next question. So here we have the function x sine of x plus cosine of x multiplied to e raised to the power of x plus x squared log x. So we consider x sine x plus cosine of x as the first function and e raised to the power of x plus x squared log x as the second function. So we have to find the derivative of these two functions, the product of the two functions. So that will be equals to x sine of x plus cosine of x, so this is the first function, multiplied to the derivative of the second function, which is e raised to the power of x plus x squared log of x, plus we consider the second function now, e raised to the power of x plus x squared log of x, and multiply it to the derivative of the first function, which is x sine of x plus cosine of x. So this is going to give us x sine x plus cosine of x multiplied to, now we're going to apply the derivative to the two functions separately. So we have derivative of the exponential function plus the derivative of x squared log of x plus e raised to the power of x plus x squared log x multiplied to the derivative of x sine x plus the derivative of cosine of x, which is equals to x sine of x plus cosine of x multiplied to, so the derivative of the exponential function is the function itself. Then we have x squared log x, which is the product. So we have to find its derivative. So we'll use the product rule. We have x squared, treating x squared as the first function, multiplied to the derivative of the second function, which is log of x, plus the second function, log of x, multiplied to the derivative of the first function, which is x squared. Then we move on to the second term. So we have e raised to the power of x plus x squared log of x times. Now we apply the product rule for the first term, for the first derivative, treating x as the first function. So we have x multiplied to the derivative of sine x plus sine of x multiplied to the derivative of x plus derivative of cosine of x, which is negative sine of x. So let's write it as negative sine of x instead of the derivative. So we get x sine x plus cosine x multiplied to e raised to the power of x plus x squared times the derivative of the logarithmic function, which is 1 over x plus log of x multiplied to the derivative of x squared, which is twice of x, plus e raised to the power of x plus x squared log x times x times the derivative of the sine function, which is cosine of x plus sine of x times derivative of x is 1 minus sine of x. So we have finally x sine x plus cosine of x multiplied to e raised to the power of x plus x squared over x, which is x plus twice of x log of x plus e raised to the power of x plus x squared log x multiplied to x sine of x. So here sine of x and negative sine of x will cancel out. So this is the final derivative of the given function. Let's move on to the next question. So here we have 1 minus 2 tangent of x multiplied to 5 plus 4 sine of x. So we have to determine the derivative of the given function with respect to x. So we treat 1 minus 2 tan x as the first function and 5 plus 4 sine x as the second function. So we have the first function, which is 1 minus 2 tan x multiplied to the derivative of the second function, that is 5 plus 4 sine x, plus the second function, which is 5 plus 4 sine x multiplied to the derivative of 1 minus 2 tan x. So that will be equals to 1 minus 2 tan x. Now we apply the derivative to each of the terms. So we have the derivative of 5 with respect to x plus the derivative of 4 sine x plus 5 plus 4 sine x multiplied to the derivative of 1 minus the derivative of 2 tan x, which is 1 minus 2 tan x. So we have a constant function here, 5. So derivative of a constant function is 0 plus. So here we can pull the 4, which is a constant, from inside of the derivative to the outside. So that means we have 4 times the derivative of sine x, and that is cosine of x, plus 5 plus 4 sine x multiplied to derivative of 1, which is a constant, is going to give us 0, minus, similarly we can pull the 2 from inside of the derivative to the outside. So we have negative 2 times the derivative of the tangent function, which is secant squared x. So we have 4 times cosine of x multiplied to 1 minus 2 tangent of x. So we have negative 2 secant squared x multiplied to 5 plus 4 sine x. So this is the derivative. Let's go ahead and further. So we have 4 times cosine of x multiplied to 1, so that gives us 4 cosine of x, minus 4 times 2 is 8, so we have cosine of x times tangent of x. So tangent of x can be written as the ratio of sine x over cosine of x, minus 2 times 5, which is 10. We have 10 secant squared x, minus 2 times 4, 8 secant squared x, secant squared x times sine x. So cosine and cosine gets cancelled. 4 times sine of x. So this is going to be the final answer. Let me rewrite it. So we have negative 8 sine of x. So this is the final derivative.